Hello. Hi.
Hello. So we'll just start. We'll wait for a few more people and then I'll just start the session.
Yeah.
Okay.
Yeah.
And
Sure.
this will be an
Yeah.
interactive one. Okay. So if you have any doubt, if you fail to understand, please stop me then and there and ask me. Okay.
Yes.
Okay. I'm starting to share my screen. Please tell me if you can see it. Okay.
Yes, we can.
Fine.
I can. Yeah.
Okay. Rachita, what about you? Hello.
Shreya, we can see. Yeah. Now we
Yeah.
can see your screen presentation. Yeah.
Fine. So I'll start at 4 5, okay? I'll just wait for a couple of minutes.
Yes. Sure.
Tell me one thing, is my video visible to you?
Yes.
Okay. Okay, so I'll start because I have to finish by 1 hour. Is it fine?
Yes. Yeah.
Okay. So before I, start solving a few questions, these questions were there in the previous year's assignments. So these are sample questions which will help the students to solve the current assignments, and this basically today's problem solving session will enable students to understand what are the prerequisites to taking this course. So firstly, I'll start with my introduction. I am Shreya. I will be the PMRF-TA for this course. So let me just start. Now, before going into everything, what do we mean by a random experiment? Any idea? Anything in simple words. Aditya?
Yeah, random experiment would be something which is, which where you take your samples at random, right? I mean, not in a where there's no bias of you picking a sample. So that would be a random experiment.
Okay, so I understand what you're trying to say, but basically, a random experiment is such an experiment whose outcome is not certain. It could be anything, like it could be random.
Oh,
And
okay.
sample space, what do you mean by sample space? What do you understand?
Sample space would be different types of samples that you are considering for your experiment that you are going to do.
No. Sample space will mean the set of all possible outcomes of an experiment.
Okay.
Okay.
Yeah.
So, and probability, as we all know, is the likelihood of any event happening.
Yeah.
And random variable is one such very crudely I'm saying, random variables are variables who can take any of those outcomes. Whose value can be any of the outcomes of a random experiment. So there
Yes.
could be
Okay.
two types of random variables. Okay, it could be a discrete random variable which we can count. Okay, and it could be a continuous random variable. By expectation, we mean the expected value, or very crudely speaking, the mean of a random variable. And by variance, we mean the degree of spread. These concepts are clear, I hope, I'm assuming. And
Yes.
this one, can you say what it lies between a probability, the range? This is always true.
Sorry, can you
0
repeat?
to 1.
0 to 1, exactly.
Yeah.
So this will always be 0 and this will be 1. Okay, and this one, probability of a complementary event.
1 minus probability of A.
Yes, 1 minus probability of A. Okay, what will be probability of A union B in terms of probability A, B?
Probability of A plus probability of B.
Probability of A plus probability of B. That's it?
That would be
And
one, right?
probability of A intersection B also.
That will
No,
be
I forgot.
minus probability
Minus.
of
Minus.
A
Okay.
intersection.
Intersection B.
What is the
B.
symbol for intersection? I don't know. I have to find out. Okay, you understood, no? This one.
Yes.
Probability of A. Probability of A. This one. Probability of A intersection B. Fine. Now, which events do you consider as an independent event? When do you say an event is independent?
When
Just
they're
a
not
second.
depend, there's no relation between two events.
That is fine, but from this equation, if I say that A and B are independent events, how would you modify this?
P in probability of P in A intersection B should be 0
Zero.
for
No,
independent.
that means disjoint. See, here
Yes.
is a problem. Let's suppose this my let's say this is your A set, okay, and this is your B set. So whatever is in A is in no way influencing, or this is your B set. So when we say it's mutually exclusive or disjoint, there is no overlap. This means that probability A intersection B equal to 0. But when we say that it's independent, we mean that probability A intersection B is probability of A into probability of B. Okay?
Yes.
So when we say it's mutually exclusive, then probability A intersection B is 0. But if it's independent, then it's just the product of the two individual probabilities. And this is the what's the formula for conditional probability? Probability A given B. Anyone? Srijani?
I'll have to think a bit. I just
Okay, so I'll write it down for the time being. It
Okay.
means probability A intersection B divided by probability of B. Okay? A conditional on B. This is the formula. And Bayes' theorem also expresses this conditional probability like this: probability B given A into probability of A by probability of B. Fine. So keeping these in mind, these are very basic formulas. I'll just hop on to the questions, okay, and you all answer. So for example, this is a question of selection. So can you see the questions, everyone?
Yes, I can see.
Okay. Rachita?
Yes.
Okay. So now this question says that if n distinct balls, note this word, okay, distinct. If n distinct balls are placed at random into n distinct cells, then what is the probability that exactly one remains empty? So how we'll solve this? Any idea? Okay. Now let me just draw these distinct cell. This is cell number 1, this is cell 2, this is cell n. Okay, so each of the n balls, this cell can contain n, all the n balls. It has a possibility. Similarly, this cell could also contain all the n balls. So the all possible ways in which these of n cells can accommodate n distinct balls is n to the power n. N possibilities here, n possibilities here, n possibilities here. So n to the power n. Okay. Is this clear?
Yes.
Okay. Now this is the all possible ways of placing n balls into n cells. Now they are saying that we have to find the probability that exactly one cell remains empty. So out of these n cells, any one could be empty. This could be empty, this could be empty, this could be empty, any one could be empty. So out of these n cells, I have to choose one which could be empty. So if I do that, how will I do it? NC1. Okay, now I have chosen the cell which will be empty, and only this cell can be empty, and number of so in let's have this one is fixed, this will be empty. So all n balls should go now into these such that none is empty. This means what? There will be one cell with 2 balls. Fine. So which of these n minus 1 cells would be that cell with 2 balls? So that can be selected in n minus 1 C1 ways, where there will be 2 balls. Now, since the balls are all distinct, which 2 balls should go here? So there are n balls. So I am selecting 2 balls which should go into this cell, let's say, with which can accommodate 2 balls. So I can select that in NC2 ways. Which 2 balls? Okay, and then I am left with n minus 2 balls and n minus 2 places, because this one is empty and this one has 2 fully occupied. So in each of these cells there will be 1 1 1 1 ball. So how can you arrange n minus 2 balls in n minus 2 cells? It's n minus 2 factorial. Now if you solve this, so what will be the final answer now? N in n C1 is n minus 1 C1 is n minus 1, then you have n minus 2 factorial n C2 by n to the power n. So this one again it means n factorial n C2 by n to the power n, which is our answer. Could you understand?
Yes.
Yes, I was able to follow up a little bit. Yeah.
Rachita?
Yes. But because it's a like conditional probability, though.
Yes, exactly. First you just have to think, and since these events are, I mean this one you understood, right? Selecting cells, then once you select that is fixed, then you move on to the next one. This part you understood,
So
right?
yeah. So if it's A conditional or B, so B is the only selecting the cells, and A is selecting. I mean, ordering the ball inside the. Wheels. Am I right?
This is if you think of it, it's like a chain of conditional events. First we do this, then we do that. Okay.
Okay. So there are more than 2 events. Like
Yes, it's not like, I mean, yes, it's not 2 events as such. This is like combinatorics things that we are doing now. It's not exactly in terms of probability, because the way I explained, I just took the total number of ways, and by the total number of favorable ways. Classical definition of probability, not conditional.
okay.
Okay, fine. So the next one is this question: given 30 people, find the probability that among 12 months there are 6 containing 2 birthdays and 6 containing 3. So there are 30 people. Okay, people 1 2 30 people are there. and the probability that we have to find this among 12 months. So this one can have a birthday on any of the 12 months. This one can also have a birthday on any of the 12 months. The 30th person can also have a birthday on any of the 12 months. So the all possible cases is 12, 12, 30 times. So what it will be 12 to the power 30. Okay. Now we have to find the probability that among 12 months there are 6 months containing 2 birthdays and 6 containing 3 birthdays. So here if 6 months have 3 birthdays, then we have 18, and 6 with 2 birthdays, then there are 12. 12 plus 18 is 30. So if we have to, which 6 months, let us suppose we don't know which of the 6 months could have 3 birthdays, and per month 3 birthday. So if we have to choose which of the 6 months contain 3 birthday, how can we choose that? By 12, see 6 ways. Fine. And
Yes.
and then once I have chosen this 6 months, I will just assign 2 birthdays in each month. So it's 30C2, then 28C2, 26C2, 24C2, 22C2, 20C2 assigned. Now the remaining, now 20, from 20 also I have assigned, I've selected 2 people whose birthday falls in these 6 months. So now I am left with 18 people. So in one of the months 18C3, then 15C3, then 12C3, then 9C3, 6C3, 3C3. So this allocation is done now. Now if we simplify this thing, 12C6, now 30C2 is 30 factorial by 2 factorial into 28 factorial. Again 28C2 is 28 factorial by 2 factorial into 26 factorial. So this goes on. As you can see, I'll write another one, 26 factorial by 2 factorial into 24 factorial. So these things will cancel. So ultimately what I am left with is 12C6 30 factorial by these 2 factorials will come 6 times, 2 factorial to the power 6, and then from here 18C3, 18 factorial by 3 factorial into 15 factorial, again 15 factorial by 3 factorial into 12 factorial. This will go on. So these will then again cancel, and I will be left with 3 factorial to the power 6 by n to the power n, which is my answer. Fine. Just a minute. Okay. So I'll move on to the next question. this one, a closet contains n pair of shoes. So if 2R shoes are chosen at random, what is the probability that there will be no complete pair? So there are n pairs of shoes, which means total 2n shoes. And out of those 2n, I am choosing 2R shoes at random. So my denominator will be 2nc2r. Okay. Now they are saying that what is the probability that there will be no complete pair? It means what? That from these n pairs, if I select, n pairs means 2n shoes. Okay, let's say this is a green one, this is a red one. So I'll have 2. This is 2n and this is the pair thing that I'm saying. So out of those 2n, if I choose, I have to, the probability is that there will be no complete pair. So from those n pairs, if I choose 2R shoes, and from that each pair, from each of the n pairs, I choose 1. Then how many will I get? nc2r 2 to the power n by 2n. Where is it? 2nc2r. From the n pairs, I am first choosing 2R pairs. And then from each of those, this will be 2R. From each of those 2R pairs, I am selecting 1 out of that pair. So there will be no complete pair in this way.
Shreya, can I give you one suggestion? So I think you should write n distinct pair. If some pairs are similar, then if I take one left shoe from one pair and the same pair I take right shoe, so it will match.
No. Yes. This should be. Why is it not working?
You have to take the cursor. So you are using only pen, na?
No, but this is not working. The cursor itself, it seems. Okay, that's the text area. Fine. This
text
one will
area,
be distinct. Yes, right. Oh, okay. This is not working for me for some reason. Okay, fine. This is distinct. I think now it should work. Again, it's not working. Fine. So then this is the next question. If x has a probability density of this one, this is the PDF of a function, okay, e to the power minus x for x greater than 0. Find the expected value of gx equal to e to the power 3x by 4. Now this one, we should note that this is a continuous function for, sorry, it's not working. Just a second. Okay, for some reason this is not working. Fine. So if you are given some function like this one is a continuous function, we can see. So expectation of gx will be integration, since it is this one is also a continuous function. This, if you see, is the PDF of an exponential distribution, if you are aware of it. Otherwise it's fine. So expectation of gx means integration of gx fx dx with over the range of x, that is 0 to infinity. Now try to solve this and get the answer. What is the answer? So this is 0 to infinity e to the power 3x, wait, insert text box answered. So this is integration from 0 to infinity e to the power
4 is answer.
4. Yes, exactly. 4 is the answer. Yes. Okay, so I'll move on to the next one. So if I extend this problem from a single variant thing to a bivariate thing, so now f of xy equal to e to the power minus x minus y for x greater than y 0, y greater than 0. We have to determine these expectations. Now I'll give a hint. Expectation of xy, this one, this is equal to, this is the range of x, this is the range of y, x into y into f of x comma y. Inside we have x, so dx dy. So for here there's no relation between the limits of x and limits of y. So y will be 0 to infinity, x also will be 0 to infinity, xy e to the power minus x minus y dx dy. Now since there's no there's no relation between the ranges of x and y, we can separate things. So for y 0 to infinity, y e to the power minus y into 0 to infinity x e to the power minus x dx. After that dy. Try to solve this one.
Yeah, I have one question. How do you define the range of x and y?
It is given here. For x greater than 0 and y greater than 0, this function is taking a non-zero value. Otherwise, it's for x minus infinity to 0, fx is 0.
So from this you are taking the ranges of x.
Yes. Okay. Always look for this thing, what is given here. So if you try to solve this one, what are you getting at expectation of xy? Oh, I understood what is wrong now.
Hey, I forgot the formula. Integration two variable integration. X into e to the power minus x. That
okay, part. This is, do you know that it is the, this is exactly, this thing is the PDF of an exponential distribution with mean 1. Okay, so this one will be 1 and this will also be 1. This part 0 to infinity x, if wait, I'll just write it here. If x follows exponential with mean equal to 1, okay, then the PDF, f of x equal to e to the power minus x for x greater than 0. So this thing 0 to infinity, this is the CDF. So this is always 1. I'm extremely sorry. This one is the formula of expectation of x. If you see, integration, give the bounds, and then x into fx dx. Can you find the similarity between here and here? 0 to infinity, this is the formula for expectation, x into fx within integration. So here also same, x into fx. And we know that expectation of x, we have assumed that, we have taken it, that mean is 1. So this part is 1. Again this part 1 will come from here, and then this into 1 dy, this will also be 1. So the final answer will be 1. Expectation of xy. Okay. So our final answer for expectation of xy equal to 1. Now similarly, if we have to apply expectation, if we have to find out expectation of x, same thing, all we need to do is just remove x, here if I have to find out expectation of x, then all I have to do is range of y, range of x into f of x comma y, y dx dy. Understood? Instead of xy, we'll only have x. Got it? Similarly for expectation of y, and this formula, covariance formula, is covariance of x comma y is equal to expectation of xy minus expectation of x, expectation of y. Is it fine? Okay. So next I'll move on to a similar sum. Here what we saw, the ranges were independent. One did not depend on the other. Now in this sum, you have been asked to find out the covariance between x and y. So covariance between x and y is the same thing, expectation of x y minus expectation of x into expectation of y. Now first we have to find out expectation of xy. So similarly, xy and f of x comma y dy dx, let's say. Now see here, x and y are not independent. The value of x depends on the value of y, where fxy is taking 2. It's 0 otherwise. So if you see this, if you draw x plus y less than 1 means when x is moving in along this direction up till here, y is moving up till here, but for a particular x, y can move only up till here. Only then will the function take some value. So if we have to decide on the range, we see that y is less than 1 minus x, and it's also greater than 0. If we allow x to move freely between 0 to 1, y should move between 0 and 1 minus x. So inside I have written dy. So I'll write here 0 to 1 minus x, and x can move between 0 to 1. So this will be the range of x. Got it? Rachita?
এক মিনিট, আমি একটা জিনিস বলছি যে হ্যাঁ ওরা নেই কেউ বাকিরা।
না, it is being recorded.
ওকে সরি।
Say.
The thing is so the range of y you're taking 0 to 1 minus x. Why not the opposite, like for
I can
range
do that.
of
I can do
y
that. Same thing. It's the same thing.
0 to 1 minus y, then for y 0 to
0
1.
to 1 minus y. So then first I am doing the integration on x, and then I'll do it on y. It's the same thing.
So we can do now.
Yes, we can do that. But you understood this part, right? Why it is going from 0 to 1 and not beyond?
Because it's less than 1.
Because of this line, x
from
plus
this
y
equation.
less than 1. Yes. Okay, so I'll move on to the next one. So here is a question of the same type: how to show a biased estimator of or if this statistic is a biased estimator of delta or not. If it is unbiased, it implies that expectation of x bar equal to delta. But here they are saying we have to show that it's biased. So it could be delta plus minus something. This is what we have to show. Okay. Now if we do expectation, firstly see something. This is a random sample, means IID, independent identical. Okay, so expectation of x bar equals to expectation of this formula x1 plus x2 plus xn by n. Now expectation has this property: if you have expectation of x1 plus x2, it can be written as expectation of xi summation by n. Okay, now since this is a random sample, xi and xi plus 1 are identical, so instead of taking this, I can also write as n expectation
nx.
of x1, any of the x's, by n. So this boils down to find the expectation of x from this formula. Now expectation of x equal to, you apply the same thing, x e to the power minus x minus delta dx. But what will be the range of x? X is greater than
0
delta.
to
No.
delta.
Yes.
Delta to infinity.
Delta to infinity. So if you solve this, you see what you get. Okay, this part, x e to the power, so x minus delta, you take it something as y. When you solve this, what is it that you get?
Okay, I'm doing. It's like delta e to the power minus 2 delta into delta minus 1, like that, delta plus 1.
I don't think so. It will be a little different. Wait.
Tell me the answer.
Delta to infinity. X e to the power minus x minus delta. Okay. So you consider x minus delta to be y. So dx equal to dy. So range changes from 0 to infinity. X becomes y plus delta. Oh, one thing is to be noted. This one, there will be a bracket here. Okay. This one I have missed. So then e to the power minus y. Then 0 to infinity y to the power minus y dy plus delta 0 to infinity e to the power minus y.
So at last it will be 0.
So
I
it
think.
will be
E to the
1
power 0.
plus delta. It will be delta plus 1.
Delta plus 1. Actually, you forgot to put the bracket. Na? That's why
Yes,
it
yes,
becomes
yes.
2 delta.
Exactly. So
Got
fine, it's
it.
not, I mean, whatever you got, it's not exactly equal to delta, right? So that
No,
is
no,
why,
not delta. Delta into e to the power minus, I mean, expectation of minus 2 delta. It was.
no,
It got like that.
see, we will not get expectation of
So the expectations are not I mean exponential.
exponent.
Sorry,
Okay, fine.
exponential.
So that is also fine. This one I forgot to put, I'm sorry. So it is not equal to delta. So that is why this is a biased estimator. If it would have been equal to delta, then we would have said that this is an unbiased estimator.
Okay.
Okay. So I have a few more questions, but I'll close the session now. And okay, thank you for joining. Just wait for 1 second. I'll just stop the screen sharing. I'll save. Thank you.
Okay, bye bye.
Bye bye.